Welcome to this deep dive into data flow diagrams. We will explore how to map information systems, distinguishing between the abstract what of business logic and the concrete how of technical implementation. Data flow diagrams map how information moves through systems. They reveal exactly where data originates, how it transforms, where it rests, and who handles it. DFDs are not one size fits all. They are structured hierarchically to manage complexity, starting from a high-level view and drilling down into specific operational details. This highest level defines the system boundary, showing the single main process and all major external entities interacting with the system from the outside world. We break down the main process into major subprocesses, revealing the primary functional areas that make up the core system operations. Further decomposition occurs here to show detailed processes, ensuring every specific data transformation is mapped out for granular analysis. We start with the critical distinction: intent. Logical DFDs describe business requirements without technology, while physical DFDs detail the specific implementation architecture. The logical DFD answers what the system does, focusing on business activities and information requirements, independent of any specific software or hardware constraints. This physical DFD answers how the system works, detailing actual hardware, software, people, and specific technical constraints required for deployment. To read or create a DFD, you must master the 4 standard symbols that represent entities, processes, storage, and the movement of information. These represent sources or destinations of data outside the system boundary, typically named with nouns to identify people, organizations, or other systems. Processes transform input data into output using verb-noun names, while data stores act as persistent repositories for information within the system. These arrows indicate the movement of data between components, labeled with descriptive phrases that explain exactly what information is traveling. Let us examine how logical models visualize abstract business workflows in diverse scenarios like hospitality, libraries, and e-commerce. This logical diagram maps guest check-ins and room bookings as abstract business activities, ignoring the specific software used to execute them. Here, the logical flow tracks book borrowing and returning as business rules, focusing on the interaction between librarians and members. Transitioning to physical models, we see how these same systems are implemented, using specific databases, servers, and user interfaces. This diagram details the specific database tables, server locations, and software modules required to manage the library operations technically. The physical view maps the specific payment gateways, inventory databases, and shipping APIs used to fulfill customer orders in real time. Creating effective logical diagrams requires a disciplined focus on business value, ensuring the model remains clear and relevant to stakeholders. Always prioritize business activities over technical details, ensuring the diagram remains understandable to non-technical business users and stakeholders. Label components with language that business users recognize, avoiding jargon that might confuse the core requirements and workflows. Regularly review the diagram with business users to ensure it accurately reflects their operational reality and information needs. Physical diagrams demand precision, as they serve as the blueprint for developers to build, deploy, and maintain the actual system architecture. Explicitly document the specific hardware, software, and network interfaces required to support the system's operational requirements. Design the flow to account for scalability and performance constraints, ensuring the system can handle expected loads efficiently. Clearly map out recovery processes and error handling mechanisms to ensure system resilience and data integrity during failures. Even experts stumble here. Avoiding these 7 common traps ensures your diagrams stay accurate, clear, and truly useful for development teams. Never mix logical and physical models in one diagram. Do not add database technology names to a logical DFD. Keep your logical model strictly technology agnostic to maintain a clear view of business processes. Ensure you show data moving in both directions. Do not just display a single arrow between entities if interaction occurs both ways. Always include bidirectional flows to accurately represent real-world data exchanges. Avoid cramming 20 or more processes into a single diagram. If a chart becomes too crowded, it loses its clarity and becomes impossible to read. You must decompose complex systems into multiple focused diagrams. Let's continue with the remaining pitfalls. Never use generic terms like just data to label your flows. Instead, use descriptive labels that explain exactly what is moving. For example, write customer order details instead of simply order. Avoid assigning multiple unrelated functions to a single process node. Each process must handle a distinct, single function to maintain logical separation. Separate distinct activities into their own unique process boxes. Mastering data flow diagrams bridges the gap between business vision and technical execution, enabling effective communication across the entire development lifecycle. Logical data flow diagrams serve as the essential bridge, translating business requirements into a clear, technology-agnostic model for stakeholder alignment. Physical data flow diagrams guide the implementation phase, providing the specific technical details needed for developers to build and deploy the system. Remember that good diagrams evolve through iteration and continuous feedback, ensuring they remain accurate as the system grows and changes. We have covered the essential principles of logical and physical data flow diagrams. Use these examples and best practices to design robust systems.